I think I'm live. Let me just get up. Give me a second. How do I? Whoops. I think I'm live. One second. I'm just trying to get the chat up. Oh, you know what I'll do? Maybe I'll get on my phone. That'll be a good shot. Hold on. Let me get up. Let me get the chat up on my phone. I think that would be better. Okay. If I'm live, um, put W's in the chat. Oh, let me see. Okay. Yeah. I think I'll just do this, you know. Yo, 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 yo. You guys can hear me, yeah? Okay. Okay, cool. I can see them. I can see them. They're flowing. They're flowing. They're flowing. All right. All right. All right. All right. How you guys feeling? How you guys feeling for tomorrow? You guys ready? Okay, cool. I'll do this. So I've got, yeah, that's perfect. So I've got my setup. I've got my phone for the chat and then my other laptop for just checking the questions. All right, cool. So, yeah, what we're gonna do today, hopefully you guys are feeling confident for tomorrow. I've just got a couple of questions, that I think can come up. So, question that didn't come up in paper one. So, modulus, implicit, differential equations, and some others as well. So what I'll do, let me share my display. So I'll share it with you, so you guys should be able to see it in a second. How do I do it again? All right, I'm gonna go to scene two, and then I'm gonna go here. All right, so now you guys should be able to see it. So now, as you can see, I've got a couple of questions here. So I've got this one, modulus, I've got proof by contradiction, binomial expansion, differential equations, implicit parametric integration, and some others. So we'll see how many we can get through. But yeah, that's pretty much it. So what I'll do is I'll let you guys, oh, no, I'm going to do it in different tabs actually. The link to find these questions is in the description, so you can access that. We'll start off with this one. So let me move this here and move that there, and then I'll let you guys have a read of it, and then you guys can tell me what you think of this question. So looking at it, it's modulus. It's got some logs in it as well. Put a 0 if you think I have no clue here. If you saw this in the exam, I'm cooked. Or put a 10 if this is very, very easy and very straightforward. Let me just get my setup on again. Give me a second. I don't know how to use these links, you know. Oh my days. One second, guys. Because I want to make sure I've got everything all sorted. How do I get clear? Okay, perfect. All right, brilliant. Okay, I think that's good. Cool. Oh, I wish, yeah. Hold on. What am I using? This Google Chrome. Oh, right, right. I know what to do. Give me a second, guys, yeah. Let me get that link up and put it there. And I think that will be better, actually. And then I can just go between there and there. Um, see, now I don't know where it is now. I do not know how to use this thing. Where is the... Sorry, guys, just give me a second. Who's calling my phone? All right. You know what? Let's just make a start. Let me just see. I'll use my phone as a thing, yeah? All right. So doing this, how do I get the PDF workbook? It's um it's in the description. So the first part of the question, it says, figure two shows a sketch of a curve with equation y equals the modulus of 2 minus 4 ln x plus 1, uh, where x is greater than k and where k is a constant, right? It says, given that the curve cuts the y-axis, given that the curve has an asymptote x equals k, cuts the y-axis at the point A, at the point A, meets the axis at point B, and as shown in figure 2, state the value of k. So remember, um, K is a vertical asymptote, so that is a restriction on your domain, right? So where you're gonna have bogey spots in this domain? It's gonna be in a logarithmic function, isn't it? Right? So remember, the argument of a log can never be 0, right? So if I set that equal to 0, x plus 1 is equal to 0, then that would mean that x will equal minus 1. So therefore, k is equal to minus 1, and that is the first answer, right? So k is equal to minus 1. And then part BI says find the y coordinate of A. Yeah. Now the y coordinate is when x is 0, isn't it? I'm just gonna think, what's the best way to do so, just so you can see the questions as well. I think I'll do this. Give me one second, guys, yeah. I'm just trying to get this up on this Mac thing. I just don't know how this Mac thing works. Give me a second. If I go on YouTube and I log in and then I just go to, let me just type this in here. Hopefully that should work. I think that should work. Give me a second, guys. That is, and then that way I can get up there. Okay. I think that's good. Okay. Perfect. All right. Yeah. Perfect. All right. So we've got that here now. And then part B, it says find the y coordinate of A. Yeah. So part B, find the y coordinate. Um, that is when x is 0, isn't it? Yeah. So if I, you know what I'm going to do actually, let me just grab this just so it's clear and we just get through it quick. So find the y coordinate of A, and then let me get the graph, and then we'll just get going very, very quickly because I know you guys have got lots of revision to do. So, all right, perfect. Okay. So the y coordinate of A, again, remember, is when x is 0. So if I plug in x equals 0 into there, we're going to have we're just going to have y is equal to the modulus of 2 minus 4 ln of 0 plus 1, like that. And then obviously that's just equal to the modulus of 2 minus 4 ln of 1, right? And we know that the ln of 1 is just 0. Yeah. So it's just the modulus of 2, which is just equal to 2, like that. Yeah. So we've got that. So that's part I. And then it says find the exact x coordinate of B. So let me just write this here. This is I. The exact x coordinate of B. Let's look at the graph again. That is going to be when y is 0, isn't it? Yeah. So how do we make y 0? Well, this whole thing would have to be 0, wouldn't it? For y to be 0. So you're literally just going to set this equal to 0 and then solve. Yeah. So I'm going to do 2. Do it here. It's going to be 2 minus 4 ln of x plus 1 is equal to 0. And then, yeah, solving that, I'm going to do 2 is equal to 4 ln of x plus 1. Divide by the 4. So 2 over 4 is equal to the ln of x plus 1. And then obviously that's a half, isn't it? So I'll say ln of x plus 1 is equal to 1 half. And then to get rid of the ln's, do the e's. So it's going to be x plus 1 is equal to e to the half. And then that way x is equal to e to the half minus 1. And that is going to be the exact x coordinate uh of what was the letter? Of B. Yeah? Let me just get this up, guys. I'm just trying to, because normally I have a setup here where I have this here. Okay, I think this is it. I think this is, okay, I've got it. Okay, perfect. And then let me just go between here. Okay, brilliant stuff. Okay, yeah, got it. Okay. So I need to use Google Chrome on this laptop. Does anybody use a Mac? I can't use Macs. I don't know how they work. I can't lie. Cannot lie. Anyways, cool. I've got the chat there, which is good. And then let me just see. Just see. Is this modulus of ln? Yeah. What did you get in your A levels? I actually failed first time. Ironically, I got an E in my first one when I did maths. I wasn't serious, and then I retook. I got an A star, and I got two Bs. Let me just see what I've got there. I'm just thinking. We all good with this? Could you also take the ln of both sides? You don't want to take the ln of both sides because remember you're trying to get rid of the ln, right? So if, for example, if you had e to the x, I don't know, is equal to 5, for example, to solve this, you get rid of the e's by taking ln's, don't you? So you do ln of e to the x is equal to ln 5, and then those will cancel, and you have x is equal to ln 5. So you take the ln of both sides when you're trying to get rid of e's, and then obviously you take e's of both sides when you're trying to get rid of ln's. Yeah. Okay. Cool. Okay. So other ones I took were business and philosophy. So yeah, that's it. So let's do the next part. So this part, I think these are the type of questions that can come up tomorrow. Yeah. So it says using algebra and showing your working, find the set of values of x such that the modulus of 2 minus 4 and then x plus 1 is greater than 3. And this is a 5 marker. So what I'm going to do, yeah, is I'm going to get this question again. I'm going to get the graph again. Yeah. And what you want to do with these questions is actually visualize it. Okay. So this one, put this here. All right. So we want it to be greater than 3. Yeah, this is the graph, right? And we want it to be greater than 3. Well, where is it equal to 3? It's just going to be a horizontal line. Now, remember what we figured out. That was 2, was it not? That was 2. So 3 is going to be above, right? So I'm going to just draw a horizontal line like that. Yeah. Now, the points of intersection are going to be the critical values. There's a point of intersection there, and there's also a point of intersection there. And what I'm going to do is I'm going to call this point of intersection, I'm going to call this x2, and I'm going to call this one, hold on. I'm going to call this one x1. Yeah. Now, where is the modulus? Where is that graph greater than the horizontal line? It's going to be for this part of the graph, isn't it? This part up here, like that, and this part up here, isn't it? Yeah. Now, for what values of x is that? Well, the answer to the question, right, if you were to think of it, right, is going to be for values of x. If I look at x2, it's going to be values for x that are greater than x2, whatever x2 is. And then it's going to be on the other side, it's going to be values of x which are less than x1. But remember, there is an asymptote at x equals k, which we said is -1. Yeah. So it's going to be between -1 and x1, like that. So this here is going to be your answer, right? So what you want to do now is figure out those critical values of x2 and x1. Does that make sense, guys? Are we happy with this? Yeah, E to A star. I was actually I was in the newspaper, you know. I remember I went to results day because I literally yeah, I just that year it was literally 10 years ago. Like I remember I got an E, I had to move my college, and then they weren't letting me do maths because I got an E, and I was like, nah, I can do it. Like trust me. They were like, nah, your E, that E is crazy, bro. So I had to move colleges, and I just locked in that year. I was just doing maths all day. I didn't even do my other A levels. I can't lie. But yeah, cool. I'm not doing mechanics today. I'm just doing pure. And how can I buy your coffee? That's much appreciated. You can. I've got a thing. I think it's in it's in my bio on YouTube. Buymeacoffee.com. If you just type in buy me a coffee, massive, then I think it should come up. But yeah, cool. So now we need to figure out these critical values. Okay. So how do we do that? Well, remember when you're dealing with a modulus function, right? My teacher always used to teach me this. Always just do it like this, right? If you've got the modulus of anything, right, then this is literally just equal to plus or minus of that same thing. Yeah. So what you want to do is say, well, we've got the modulus of 2 minus 4 ln of x plus 1, like that, like that. Now, this is either equal to the positive version of it, like that. You don't even need to write this bracket, but I just write just to really reinforce it, like that. So I put in minus plus 1, like that. Or it's equal to minus of it. Now, remember, when you have a modulus function, right, it's literally a piecewise function. It's two functions put together, and it's just the same function. One is a reflection of the other, right? So the question is, which one is it? Yeah. So what I'm going to do is, let's actually see which one it is. So if I was to expand this one, right, that one, that's just going to literally be 2 minus 4 ln of x plus 1, like that. And then this one, if I expand that, it's going to be minus 2 plus 4 ln of x plus 1. And the reason why I'm doing that is because now that I know that this 4 ln, this ln term is positive, right? I know that it's going to represent this part of the graph, isn't it? Like that. It's going to represent this part. This graph here, whoops, let me get a pen here. This graph here is the positive version of the ln, which is that one. Yeah? Which is that one. So that x2, right, is going to be solved when I make that equal to 3, right? So let me just write y equals there. So this part here, y equals, and what I'm going to do, so just so it's super clear, right? This graph here is y equals minus 2. Hold on. Y equals minus 2 ln, minus 2 plus 4 ln x plus 1. And this one here, and I'll do it in blue. I'll just do the whole thing. This one is going to be the negative one, like that, which is going to be 2 minus 4 ln of x plus 1, right? So I'm going to solve both of these and make them equal to 3. Now, it's important because you need to know which critical value you're looking for. So x2 is going to be when I solve this one equal to 3, and x1 is going to be when that one is equal to 3. So therefore, I'm going to solve, which way have I done it? Yeah, that one's that one, that's fine. So I'm going to now solve both of these equal to 3, yeah? So minus 2 plus 4 ln of x plus 1 is equal to 3. That means that 4 ln of x plus 1, hold on, do it like that. So you can see it is equal to 5. So that means that ln of x plus 1 is equal to 5/4. And then that means taking e of both sides, x plus 1 is equal to e to the 5/4. So therefore, x is equal to e to the 5/4 minus 1. And this is going to be our x2 value, isn't it? Right? E to the 5/4 minus 1, right? So therefore, our answer so far is going to be x is greater than e to the 5/4 minus 1, right? Because we've got that critical value there. Now we need to just get the other one by making this equal to 3, isn't it? Yeah? Okay. Let me just make sure that let me just check the chat. Now it's all good in terms of the Mac. I've got it all sorted now. I've got it all sorted. It's just think with Google Chrome, right? Obviously, you can get tabs, but if you have Safari on Google on the Mac, right, you can't open tabs. I don't think because I was getting proper confused. Because what I have basically, I'm doing the lesson here. Then I've got my brother's Mac where I've got this stream up and I've got the solutions as well, just to make sure I've got everything correct as well. But I couldn't switch between tabs, but I've got that sorted now. But yeah, you can find these questions, the ones that I'm doing. Is the link is in the description of this stream, right? It's a workbook. It's just one note. It's one crazy long link. Anyways, so we've got that critical value. Let's make this one equal to 3 and solve it. So if I make that equal to 3, like that, then you know what? Let me just do it underneath actually. So it's super clear. So I'm going to do 2 minus 4 ln of x plus 1 is equal to 3. And then that means if I move that there and I move that there, then I'm going to have 2 minus 3 is minus 1. That's going to equal 4 ln of x plus 1. Divide by 4, it's going to be minus a quarter. It's going to equal the ln of x plus 1. Take the e of both sides. So it's going to be e to the minus a quarter is equal to x plus 1. So therefore, e to the minus a quarter minus 1 is going to equal x, right? And this is going to equal our x1 value, and that was x2. So therefore, that one is going to be this one here. So it's going to be minus 1 x, and then that value, which was what? E to the minus a quarter minus 1. Quarter minus 1. So these are going to be your two answers here. Put that there and copy that. And that is literally it. Does that make sense, guys? Everybody happy with that? Let me zoom out so you can see all the work. And there's quite a bit of work in there. But let me know if you guys have any questions. Let me just check that as well. Yeah, good stuff. Got that. What time are you streaming to? I think I'm gonna stream to maybe like 9:30 or maybe less than that. I have a maths degree. Yeah, I do. Yeah, how would we know which the positive neg? So remember, the positive one, remember the graph of ln. This is just a graph transformation of ln x. Remember, you should know ln x, right? Literally looks like this. It is increasing like that. Yeah. So if I was to reflect, this is y equals the positive of ln x, right? If I was to reflect this in the x-axis, it will literally just look like this, wouldn't it? Like that. So could you see the one going down is going to be minus ln x. So that way I know that this blue one is going to be the negative one. And it makes sense because it's got a minus there. That's how you know which one is positive and which one is negative. Does that make sense, guys? Yeah. Okay. Okay. And then can you explain the inequality of minus 1 for sure? So remember, right? The question is asking you to use algebra to find a set of values for x for which this function is greater than 3. Now remember your function here, right? This graph has a vertical asymptote, doesn't it? Right? It doesn't go past x equals minus 1. Yeah? Can you see? So therefore, right, where is the graph between it? It's between it for this part here. This is x equals minus 1 right here. This value here. This is x equals minus 1. And then this right here, right? That was, which one was that again? That was e to the minus quarter minus 1. X equals e to the minus a quarter minus 1. So can you see the graph, right, is above that horizontal line for this region here, like that. And the first point is that critical value, e to the minus half minus 1. The other side is x equals minus 1. So the graph is above it in between those. Does that make sense, guys? Yeah? Find out which is positive. Would you put it in the cap to see the actual answer? Yeah, let me just see. Cool. Cool. Yeah. Yeah. The positive answer is e to the 5 quarters minus 1. Yeah. Okay. Apologies if you're lost. What you can do, remember, you can always go back and watch this, right? But yeah, I'm gonna how did you find the asymptote? Remember, the asymptote, remember, just look for the bogey spots of your function. You know that the argument of a log can't be 0. So you set it equal to 0. X plus 1 is equal to 0. X equals minus 1. That was the first question. Yeah? Okay. Good stuff. All right. Cool. So I'm gonna continue now. So you've done that one. Let's go to another question now. So go back to questions and then let's do proof by contradiction. So let's do this one here. I'm gonna just do. I think it's neater if I do it like this actually. Proof by contradiction. Contradiction. Okay. So looking at this one, guys, what do you guys think of this one? Put a 0 if you don't know what to do. Put a 10 if this is light work. This is very, very easy. Your chair looks so comfy. It is. It is. It was expensive though. It was like £140, but it's worth it. It's worth it. You should have seen what I was sitting on before. Maths A level, you're talking about a chair. Allow him. Okay. So, okay. So let's have a go at this one. It says you've proved by contradiction to prove that the curve of equation y equals 2x plus x cubed plus cos x has no stationary point. So remember your first mark with proof by contradiction, right, is you're proving the opposite, right? So you assume the opposite. So you assume that it does have stationary points. So step one, you're gonna say assume y equals 2x plus x cubed plus cos x has stationary points, right? That will give you 1 mark. Always state your assumption, right? Assume the opposite, right? And then now, what you want to do is, okay, say fine. Well, if it has stationary points, that would mean that dy dx is equal to 0. So what you want to do is differentiate it, find out what dy dx is, set it equal to 0, and then you should arrive at some contradiction, yeah? So let's differentiate it. Dy dx is going to equal, differentiating that is going to be a 2 plus 3x squared. And then that's going to be minus sine x, isn't it? Like that. And this is equal to 0. Now, how do we solve that? Well, what I'm going to do is I'm just going to move the sine x to the right. So I have 2 plus 3x squared is equal to sine x, right? And then I'm just going to write it like this. Sine x is equal to 3x squared plus 2. Now, we know how these types of questions work, right? It's a contradiction. We're looking for some contradiction. So is there anything wrong with this formula here? Maybe. Not formula. Is there anything wrong with this equation, I should say? Hold on, guys. I just need to sort something. Let me just see. Okay. Whoops, I need to just something's going on here. All right, let me just do that quick. Okay. So let me just see. Exactly, right? So I'm just sorting something. Okay, perfect. I had to just paper something quick, guys, on my phone. Anyways, cool. So, ugh, oh my days, I'm finished. I'm so finished. Anyways, okay, so yeah, sine x is equal to 3x squared plus 2. What's the problem with that? Well, if you look at this, right, sine x, we know oscillates between 1 and minus 1. It's like this, isn't it? Right? 1 minus 1, right? 3x squared plus 2. What does that look like? The minimum point is 2, right? The minimum point is 2. The maximum point of sine x is 1. There's a contradiction. These can't ever be equal, right? So what you're going to say is that sine x, so you're going to say sine x, right, goes between minus 1 and 1, and 3x squared plus 2 is greater than or equal to 2. Therefore, they can never intersect, right? This is a contradiction, right? This is a contradiction. And so, therefore, y equals, what was the original equation again? 2x plus x cubed plus cos x has no stationary points. Something like that. Does that make sense? Yeah. No, guys, I don't even know how it works, with honestly, with the YouTube stuff in terms of the ads and stuff, right? I just literally let there's like an option on YouTube Studio where YouTube just says they'll do the ads for you. So I don't know how that works, but obviously you guys know, obviously, like um uh obviously I do these for free and stuff, so obviously having ads on helps to support the channel, you know what I'm saying? So maybe what I can do for next time is I can have a look at how to maybe stop the ads being, maybe if they're too aggressive. I'm not sure how they work, honestly. So you guys are too funny. But yeah, is everybody happy with this question? Yeah. Hello, agreeable zero. I hope you're good. Jack, you're good, bro. How you doing, bro? Okay. What did you do after A levels? I went to uni. I went to University of Leicester and I did maths. Yeah, I can't lie, guys. YouTube Premium is the one. I can't lie. I have it. I got it for 1 month. I've never looked back. I can't lie to you. I can't lie to you. It's a bit spenny, but I can't lie. It's worth it. You're on the train or you're traveling. You can download. I'm telling you guys, man. I'm telling you. Okay, so we've done that. Let's do this one. Differential equations. This is 100% coming up. 110% coming up. So you see. You guys are too funny, honestly. Okay, we put this there. Okay, okay. So, what do you guys think about this question, guys? Put a zero if you don't like this question, you don't like differential equations, or put a 10. It's very, very easy, very straightforward. The live is probably gonna end around 9 o'clock, 9 to 9:30 maybe. Uni was calm. I can't lie. It was bliss. I can't lie. I had a friendship group. We were all on the same page. We had a group chat. We called it Finesse Gang. When it was time to do assignments, everybody slapped the answers in the GC. And then obviously you got to do the exams by yourself, but it was calm. It was calm. All right. So let's have a go. Let's have a go at this one. There are too many words. All right. Let's look. So it says the number of goats on an island is being monitored, right? When monitoring began, there were 3,000 goats on the island. In a simple model, the number of goats, x in thousands, is modeled by the equation x is equal to k bracket 90 plus 5 over 40 plus 3, where k is a constant and t is the number of years after monitoring began. Part A says show that k is equal to 1.8. So let me grab everything I need and then I'll just do this underneath, yeah? So um all right. So to find k, right, we've got three letters. We've got x, k, and t, right? To find k, it would be great if I had a value for x and a value for t, right? And I do because they've told us a bit of information. When monitoring began, there were 3,000 goats on the island, right? So what does that mean? Began, initial, at the start. That's quite clearly t equals 0. Yeah. Now, at the start, there were 3,000 goats. So X is equal to 3,000. Is that correct, guys? Yes or no? I think I'm so behind, when I'm looking at the stream here. Oh, right, 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 right. Hold on. Okay, cool. Am I playing? Okay, cool. So yeah, no, it's not, right? Remember, X is in thousands, isn't it? Yeah, so you've got to be very, very careful. Well done, Cleopatra. Fantastic. Well done, Guy. Well done, Diddy. Good stuff. Everyone, good. Well done. Well done, guys. Brilliant. So X is equal to 3, right? So remember, X is in thousands, so they can do that sometimes where they like to do that. Hold on. Let me cross this out and put 3 because it's not letting me rub it out. Hold on, if I do this, because I think my thing is glitching. Let me just close this quick. Close window and open it again, and then that should do it. Because I think it wasn't letting me rub stuff out. So let's try that. Hopefully that works. So rub out. Yeah, perfect. So x equal to 3. So all I'm going to do now is substitute those in. Yeah. So it's going to be 3 is equal to k lots of 0 plus 5 over 0 plus 3, like that. So that means that 3 is equal to 5k over 3. So that means that times by 3, that's 9. 9 is equal to 5k. And that means that 9 over 5 is equal to k, which is equal to 1.8, isn't it? So therefore, k is equal to 1.8. So we've got k now. So that's done. Part B. What does part B say? It says, hence calculate the long-term population of goats predicted by this model. So now that we've got the value of k, we've got a complete model for this, for the goats, right? So what was the formula? It was that there. So let me grab that and then put that as 1.8. Like that. Now, whenever you see these types of one markers, guys, long term, right? Let me just replace it with 1.8. So x is equal to. See. Okay. Okay. So x is equal to 1.8, 9t plus 5 over 4t plus 3. All you want to do, guys, right? If worst comes to worst, just plug in a really, really big number, right? Just plug in a really, really big number and see what happens. But you can do this algebraically, right? Whenever you got these types of rational functions here, just divide everything, right, by the most dominant term, right, which is a t. So if I divide all of these by t's, right, it's going to be 9 over t plus, sorry, not 9 over t, it's going to be 9, sorry. It's going to be 9 plus 5 over t, like that, over 4 plus 3 over t, like that. And then what you want to do is say, well, what will happen as t gets really, really big? These expressions here are going to disappear, aren't they? Like that. Yeah. So yeah, they're going to disappear. So essentially what you're doing is you're going to say you're doing the lim as t tends to infinity of that, right? And what's going to happen is that that is just going to be 1 times 9, 1.8 times 9 plus 0 over 4 plus 0, essentially. So you're going to literally just put this into the calculator and see what you get. 1.8 times by 9 over 4. That is equal to 81 over 20, which is 4.05, like that. Yeah. So therefore, the long-term model uh, states that x is going to be 4.05. But remember, x is in thousands, so you got to times it by 1,000. So it's going to be 4,050. So 4,050 goats. That's what the model predicts. Like that. Everybody happy with that? Yeah. And this is what is this caps thing everybody's talking about? I don't get it. Is that like a joke? You know me, I'm an unk, so I don't really get what you guys be saying sometimes. But yeah, is everybody happy with that? Yeah. And again, what you could do, guys, just plug in a really big number as well. Just plug in a really big number. I'll show you as well. If you were to plug in a really big number into that formula, like that. So if I do 1.8, let's say I always use 10 to the power of 10. That's a really big number, right? If I do that and I do 1.8 times 9t, so 9 times answer plus 5 over 4 times answer plus 3, we get 4.05. Yeah. So again, if worst comes to worst, so you don't like this thing that I've done, you can just plug in a really big number. Okay. Cool. So y divide by t. So it's just an algebraic, it's just a technique, it's a trick, right? To help you look and find out what happens as a function gets really, really big. It's just a trick. Yeah. So yeah, again, if you don't like that, then you can just plug in a really big number. So we've done that. Now let's continue. So it says in a second model, the number of goats x in thousands is modeled by the differential equation 3dx dt is equal to x 9 minus 2x, right? Part C says write 3 over x times 9 minus 2x in partial fraction form. So doing that, let's do that and see what we get. So doing that, this is pretty straightforward, right? So it's going to be, we're going to say 3 over x 9 minus 2x is going to equal a over x plus b over 9 minus 2x. And then that means times everything up. So you're gonna have 3 here, times both sides by the denominator. You're gonna have 3 is equal to a, and then cross multiply 9 minus 2x plus bx, like that. And then you would have just set each of these brackets equal to 0. So if I set that equal to 0, what's that? 9 minus 2x is equal to 0. 9 is equal to 2x. 9 over 2 is equal to x. So I'm going to set equal to 9 over 2. So that way I'm going to have 3 is equal to, that will disappear. It's going to be b times 9 over 2, like that. And then that would mean that I'm going to have times that by 2. That's going to be 6 is equal to 9b. So 6 over 9 is equal to b. So therefore, divide top and bottom by 3. It's going to be 2/3. So b is equal to 2/3, right? And then obviously to get a, we're going to set x equal to 0, aren't we? So I'm going to set x equal to 0. I'll do it here. So that's 1. Set x equal to 0 for 2. That will give me 3 is equal to b will go, it will be a times 9, wouldn't it? So therefore 3 over 9 is equal to a. So therefore a is just equal to 1 over 3. So therefore a is equal to 1/3 and b is equal to 2/3, right? Now remember they said set it, write it in partial fraction form. So the final answer, I'll just actually write it in the form. So it'll be like this. So it'll be equal to 1 over 3 and then x plus, and then b is going to be 2 over 3, like that, and then 9 minus 2x, like that. And then obviously what you can do is bring the denominators, these can go down like that, but I like to take them out, to be honest. So you can write like this: 1 over that 3 will times with the denominator there, and then plus 2 over 3 and then 9 minus 2x if you want, like that, or you can expand it. But yeah, that will give you the 3 marks. Yeah. Non-stop live stream ads will play while you watch. No way you got ads to live. Yeah, honestly, in terms of the live, I mean the ads, I don't know how it works. Literally, I just put on, I just go on the YouTube studio and it just says, do you want us to do the ads for you? I don't know how it works, but next time I'm gonna sort that out if it's quite um annoying. But yeah, cool. So yeah, that's done. Part B. So that was part B. So no, that was part C. We're on part D now. Okay. I don't think this question's that bad, you know. So part D says solve the differential equation with the initial conditions to show that x is equal to that. Right? So at least we've got what we're looking for, yeah? So we've got this here. We got that. And then what was the actual equation? The differential equation was here. Okay. So we got this one. And then let's see where we're at. So we got this here. We need to solve the differential equation with the initial conditions. Remember, the initial conditions, right, was when monitoring began, there were 3,000 goats. So when t was 0, x is 3. So let me write that as well. T equals 0, x equals 3. That is the initial conditions there. T equals 0, x is equal to 3, right? So we need to solve this, and we do that by obviously separating the variables, don't we? So I'm going to do that, and at least we have what at least we have what we need to get to, which is good. So separating the variables, remember the x's go with the x's, and the dt's go with obviously the t's, but there's no t here, so you can just leave it as a constant. So I'm going to keep the 3 on that side, times it up. So it's going to be 3 over 9, sorry, 3 over x, sorry, 9 minus 2x dx, right, is going to equal dt, like that, right? And I can put integral signs. Now, the reason why I'm doing like this is because obviously in part C, they asked us to express this in partial fraction form, and that's obviously for a reason, so we can integrate it, yeah? So this was the partial fraction form. And what I'm going to do, I'm going to use this one, right? And you'll see why in a second. So what I'm going to do is I know that that is equal to that. These are the exact same thing. So I'm going to put integral signs like this, like that, and then that will equal dt. Is everybody happy with that though? Yeah? Okay. Let me appreciate you, immigration office. Thank you very much, man. Oh, Jack, I was about to give you mods. So because I gave you mod that time before, you still are mod. Is that how it works? I did not know. That is sick. That is sick. Okay. So yeah. So what I'm gonna do now is we need to integrate both sides, yeah? Now, how do we do that? Well, what I like to do with these ones is just take out the factors. These both have a common factor of a third, right? If I take out a factor of a third, right, I will get 1/3 and it would be times by 1 over x, like that. And then plus, and then because it's 2/3, if I take out a third from that, it would be times by 2 over 9 minus 2x dx, like that. And then from here, let me just make sure, because it looks a bit too far away to be fair, like that, yeah. Then if I take that out, right, I can take out a common factor of that third, and then I can put that on the outside of the integral. So I have a third, and then I'm gonna have 1 over x, and then it's gonna be a plus 2 over 9 minus 2x dx. And then this is the integral of dt. And then now I'm going to integrate. Yeah. So only one mod per stream, I'm afraid, or recall. Yeah. Maybe next time. Yeah. So let me just check. We're all happy with that, right? Yeah. Good stuff. So now integrating both sides now. We're going to have a third. And then that one is going to be the ln. I'll put a big bracket. It's going to be the ln of x, right? Now x is in goats. X is positive, so I can leave the modulus sign. But if I don't, just always be aware of your argument, right? If you see any problems with it where you have negatives, then obviously just put them on. Yeah. So I'll just leave it off for now. And then this one, how do I integrate this? Remember, look at the denominator. Whenever you're integrating fractions, guys, look at the denominator. Yeah. When I differentiate 9 minus 2x, I get a minus 2, right? So for example, if they ask me to integrate minus 2 over 9 minus 2x, right? Then immediately that will just go to the ln of, I'll put modulus sign on this, 9 minus 2x plus c, yeah? Because the numerator is the exact derivative of the denominator. However, we don't have that. We just have a 2. So it's essentially the reverse chain rule. What's happened? Well, it's just times by minus 1. Yeah. So the answer is just going to be minus the ln of that. Yeah. So I can put a minus there. So I put minus ln and then 9 minus 2x. I'll put a bracket like this here. And then put a big bracket like that. And then this is going to equal, now the integral of dt, remember this is a 1 dt. That's just going to be t plus our constant of integration. So we're here now. Now, when you get here, guys, right, this is going to be your general solution. Yeah. It's going to be a general solution. So let me move this up like that there. We call this the general solution. Now, when you're trying to find out your constant of integration, that's when you use the initial condition to get a particular solution. Yeah. So we're going to use those initial conditions. Remember, they told us that t equals 0 and x equals 3 were initial conditions, right? So I write this here again. So t is equal to 0, x is equal to 3. Oh, let me do it a bit here to the side. Let me do it like this. T equals 0, x is equal to 3. Plugging that in, that's going to be a third, and then that's going to be ln, put bracket here, ln of, you know what, yeah? It doesn't matter, to be fair. Let me put in like this and then do it after. It doesn't actually matter. So it's going to be 3 minus the ln of 9 take away 6, which I'm going to simplify in a second. Like that. And this is going to equal, t is 0, so it's going to equal that there. And then that one's going to be third of ln of 3 minus 3, like that. And they just cancel, don't they? Right? ln 3 is just 0. So that just goes. So therefore c is equal to 0. Yeah? Happy with that, guys? Yeah? Perfect. So now we've got c is equal to 0. We can say that our particular solution, right? Put this here. C is 0. Can remove that. This is going to be our particular solution. Okay. Perfect. So now, let me just go back to chat. Okay. Okay. So now we've got that. Now remember what the question asked us to show. It said solve the differential equation with the initial condition to show that x is equal to that. So it's a show that question. So we know where we need to get to. So we found out what this is. So now we just need to use algebra to show that we get this expression here. Yeah. So let's go ahead and do that. So firstly, what I'm going to do is I'm going to write 1/3, and then in the bracket, I can use log laws to simplify that. That's just going to be x over 9 minus 2x, isn't it? Like that. And then that's going to equal t. And then now we want to get x by itself. So let me times up the 3. So it's going to be the ln of x 9 minus 2x is going to equal 3t. And then remember, because we want x on its own, we need to just rearrange. So I need to get rid of the ln. So I'm going to raise it with both e's. So it's going to be x over 9 minus 2x is going to equal e to the 3t. Like that. And then times it up, it's going to be x bracket, and then it's going to be e to the 3t 9 minus 2x. And then because I want x on its own, I need to get all of the x terms on the same side. Yeah. So I'm going to expand. It's going to be x is equal to 9e to the 3t minus 2x e to the 3t, like that. And then I'm going to move this term to the left, right? So I'm going to have x plus 2x e to the 3t is going to equal 9e to the 3t. And then now we can take out the x, because that's what we want. It's going to be, what's it going to be? It's going to be 1 plus 2e to the 3t. And that's going to equal 9e to the 3t. And then now we can divide. So x is going to equal 9e to the 3t over 1 plus 2e to the 3t. So we've got x on it. So let's just compare it to what we want, right? Now, I've seen this come up before. I think this has come up, right, on a specimen paper, like this type of differential equation where you get to this part here. And for some reason, they really like this format, right, where they have the exponential to have a negative in the c. So when you're here, well, how do you just compare them? Let me write it in the same order. Let me swap the denominators over. So 9e to the 3t over 2e to the 3t plus 1. It looks very similar. All you're going to do, right, if you can just use this to help you out, you've got an e to the minus 3t there, right? You need to make that appear somehow. Well, what you're going to do is you're literally just going to times top and bottom by e to the minus 3t, like that. And then what will happen is that, well, remember, the numerator, that will cancel with that, won't they? Yeah, so that's just going to be a 9 on the top. And then if you do it like that, you expand in the bracket. This one and that one, the e's will cancel, will just be 2. And then this one is just going to be e to the minus 3t. And that is it. Does that make sense, guys? Yeah, c was 0. C was 0. Yeah? Everybody happy with that? Most of Dan Chris MD collab is needed. That's the footballer, right? So are you passionate about maths? Yeah, I would say so. I would say so. I think this is all I know, to be fair. Anyone that knows me is like, this is all I know. Like, um, I would say I'm an intelligent guy, but in terms of like street smart and just general knowledge and just common sense, I'm not the sharpest tool. So maths is all I have to fall back on. So I have to be passionate. But yeah, cool. Let's have a go. So yeah, we've done that. Now let's continue. I think there was one more to this question here. Um, okay. So it says, yeah, find the long-term population of goats predicted by this second model. So this is our second model here, right? So it's really similar to what we did before, right? In the sense where you want to just investigate what's happening to the function, right? So this is the function here. Let me grab it. I've got it here. Now, again, if worst comes to worst, guys, just plug in a really fat number, right? But again, you don't have to do that. If you inspect this algebraically, right, you've got x is equal to 9 over 2 plus, and I'm going to write this as a fraction. It's going to be 1 over e to the 3t, right? Long term, that means as t goes to infinity, right? What happens as t gets really, really big? As t gets really, really big, this is going to become 0, isn't it? Because we're doing 1 over an exponential. Exponentials grow exponentially. It's going to increase rapidly. So essentially, as t goes to infinity, right, then you're just going to have x is equal to 9 over 2 plus 0, which is just 9 over 2, which is 4.5. Yeah, now remember, x is in thousands, so you're going to times that by 1,000. So it's going to be x equals 4,500 goats. And that is the long-term population of the goats. Yeah? Everybody happy with that? Here's a question. Are you a maths teacher or you enjoy subject? So I don't teach in a school. Um, I literally just tutor full time. So yeah, I do YouTube videos and obviously yeah, I do tutoring lessons and stuff. So yeah, this is my full-time job. So it's fun because obviously I do it just completely remote. So it allows me to like to travel and stuff and yeah, I enjoy it. I enjoy it. I enjoy growing it and yeah, just yeah, I enjoy it. It's fun and teaching maths. So it's good. But yeah, okay. Can you explain how you did the 9 minus 2x derivative, please? What's the trend? Allow me, man. Allow me, man. I've been grinding. Do you get me? But yeah, I'll show you again. Um you guys are too funny, honestly. Where was it? Where was it? Where was it? Where was it? It was no, we did it here, didn't we? Yeah, it was here. So when you have whenever you're asked to integrate a fraction, right, you should always inspect the numerator. So for example, let's say I don't know, let's say I had 2x over x squared, like that dx, yeah. Now, because of the fact that the denominator, right, when you differentiate the denominator, you get the numerator, you're just literally gonna do ln of x squared. It's literally just it's a rule in the book, right? If you've got the integral of f dash of x over f of x, right? Like that, dx, then the answer is going to be ln of f dash of x, f of x, sorry, plus c. Yeah. So with this one, when we had the integral of 2 over 9 minus 2x, right? When we differentiate the denominator, right, we get minus 2. However, we have a 2 there. So it's just a matter of a constant, just multiplying by minus 1. Yeah? Does that make sense? Yeah? Okay. Okay. Just see. Oh yeah, Daniel Stone. Yeah, yeah, yeah. That's what I would be saying, isn't it? So let me get rid of that. Let me not write x equals 4,500. I should say 4,500 goats. Yeah, technically you're right. But yeah, cool, cool. Okay. How does E end up being zero if E never hits zero? So it doesn't actually become zero. Well, what we're saying is that it gets so small that it may as well be. Does that make sense? Yeah. So it's like, whoops, the graph. So if I do like this here, like that, remember e to the x is like this, yeah? Look, let me do e to the minus x. E to the minus x is like this, like that, yeah? It never actually gets to zero, but as x gets crazy big, it's essentially going to be nothing. That's what we're saying here. Hope that makes sense. Yeah? Okay, cool. Good stuff. So yeah, we've done that one. Let's go to the next question. What else do we have here? So we've done that one. Okay. Let's do some binomial expansion. See how we get on. So I think we're doing well with timing. How many questions have we done? One, two, three. That was a long question though. So 4 questions so far. I think that's okay. Paste binomial expansion. How do we find binomial expansion, guys? Put a 0 if you don't like it at all. Put a 10 if it's light work. This is an easy 5 marking exam tomorrow. So do you rate me? Of course, bro. Okay. Okay, good stuff. Good stuff. I haven't got any harmonics today, but I've got a few. I've got a few on my channel, and I think in my predicted paper, so you can have a go at that. But yeah. So this one here, I'm actually quite far off. Okay. Okay. So perfect. All right. It says find the first four terms in the ascending powers of x of the binomial expansion a over 2 minus 5x all to the power of 2. Write each term in simplest form. So remember, your general formula when you're dealing with binomials with fractional and negative indices is going to be if you have 1 plus ax to the power of n, this is going to equal 1 plus nax. Sorry. 1 plus nax plus n minus 1 over 2 factorial ax squared, and so on and so forth, right? So that tells you that you need to have a 1 there. So we got to do a bit of algebra first before we start dealing with this. So I've got 8 over 2 minus 5x all to the power of 2. I can rewrite this as 8 and then bring the denominator up. So it's like that. And then remember, we need a 1. So I'm going to take out a 2. Yeah, so it's going to be big bracket, take out a factor of 2. It's going to be 1 minus 5 over 2 x all to the power of minus 2. And then from here, if I have a product and I've got a power, then we can just split it like this. It becomes 2 to the minus 2 and then times 1 minus 5 over 2 x to the minus 2. Like that. And then what's that? That's 2, no? Because, sorry, yeah, that's definitely 2. 8 times 2 to the minus 2 is 2. Put it in your calculator like that. And then you get that there, right? So what we need to do now is what we need to do now is just apply this formula here, right? So put this formula down here. So it's going to be equal to, so we're going to have, I'll do a 2 and then 1 minus 5 over x to the power of minus 2. That's going to equal 2 and then a big bracket. And then now I'm going to apply this formula here. So it's going to be 1 plus n, by the way, is obviously minus 2. So it's going to be minus 2 and then ax is the minus 5 over 2x, isn't it? Like that. And then plus n, which is minus 2, times by n minus 1, which is minus 3, over 2 factorial, and then minus 5 over 2, x to the power of 2. Like that. What term do they want? How many terms? They wanted it the first 4. So that's up to x cubed, isn't it? So I'm going to do the next one. So let me just zoom out a bit and then do the next one. So it's going to be plus, and it's going to be minus 2, minus 3, minus 4 over 3 factorial. And then it's going to be, let me just write this here actually so you can see. So it's n minus 1, n minus 2 over 3 factorial, and then ax all cubed. Yeah. So then following that, it's going to be minus 5 over 2x all cubed. Like that. Everybody happy with that? So do you have a steady income? I try my best, you know. I try my best, put it that way. I try my best. You know, as an adult, you know, you guys will get there soon. You just got to make ends meet, and as long as you can do that, then you're good, you know. So yeah, okay, cool. So doing this now, what you want to do here is you just want to tidy up. So I've got this 2. I'm going to leave it like that. I've got 1, these 2, this term here. The minuses will cancel to be plus. 2's will cancel, so that's going to be a 5x. Like that. And then this one, now when you get to these ones, guys, so I always do, yeah? It's so simple. You'll never get it wrong this way. To get the coefficient of any term, just literally isolate the x squared, or isolate the x term, I should say. Yeah. So this one here, remember, you can literally write this as this right here, you can write as minus 5 over 2 all squared and then x squared, isn't it? Right? And then you've got this there. So all I'm going to do is literally plug this into my calculator. No delay, right? And you'll get it easy. Yeah. So putting that in, that's going to be minus 2. By the way, obviously, I know that's positive 6 over 2, which is 3. But in an exam, listen, I'll write 1 plus 1. I can't lie. Always just write it how you've written it. Yeah. And then obviously minus 5 over 2 all squared like that. And that is equal to 75 over 4. So that is going to be 75 over 4x squared like that. So that goes there like that. And then the next one is that one there. So I'll grab that. So that one again is just literally going to be minus 2. This is for the x cubed coefficient, by the way. Minus 4 over 3 factorial. And then it's going to be minus 5 over 2 all cubed and then x cubed. And then again, guys, just put this into your calculator. Yeah? Okay. What do you think the hardest topic that will come up tomorrow is? What is the hardest topic in pure? Maybe integration, per parts, parametrics. What questions normally come towards the end? Harmonics, trig. Yeah. Should we have to? Should we have 2 to the power of minus 2 on the outside? I times the 2 and the 2 to the minus 2 to make 2. Or no, it was 8 I did. Yeah, so I think I already simplified that already. Yeah. So after I'm gonna type everything by 2, so I'm gonna put this in the calculator. So that one is gonna be hold on, let me go up there. I'm gonna change that to a 3 factorial, and then I'm gonna do -4 like that. And then 2, that's fine, that's fine, that's fine. I'm gonna change it to a cubed. Like that. And that gives us 125 over 2. Yeah? So therefore, that's going to be 125 over 2x cubed, like that. So I get that there. 125 over 2x cubed, like that. So now, all I need to do now to finish off the question is just literally expand that 2. Like that. So doing that, that is literally just going to be equal to um 2 plus 10x plus, that's going to be 75 over 2x squared. And that's going to be 125 x cubed. And that is going to be the final answer. Everybody happy with that? Okay. Okay. Cool. So all good. So let's do the next one. Did you do C1, C2, C3, C4 back in the day? So what raw marks did you get in your A level maths? I said I couldn't speak. Yeah, I did. You know, yeah. Before I tell you what I got, yeah, I have a friend, yeah. I'm gonna click this and send it to him, yeah, because he's my guy, yeah. His name is Marvelous, yeah. He is the coldest at maths. He's the coldest. I'm gonna get him to come in one of these streams, yeah. Listen, so basically, there were 6 exams. So there was C1, C2, which is like year two. There's like year 12 maths. It's like AS maths. C3 and C4 are like your paper one and paper two. And then you had an option to pick either mechanics, statistics, or decision, right? So I did obviously C1 to C4, and I did stats and mechanics, yeah. So basically when I flopped, right, I got an E. So what you did normally is in year 12, you did 3 exams, C1, C2, and then one of the options. And then in year 13, you did another 3, right? C3, C4, and then your other option. Because I did so badly, I did all 6 in one year. So I did C1, C2, as well as C3, C4, and M1 and S1, right? Mechanics and stats. C1, I think I got like, I don't even think I killed it like that. I got like 83 or something. I remember what I got overall. C2, I got like 87 or something like that. C3, I got 100 UMS, 100%. I can't lie. To this day, that's the best exam I've ever done. Like uni, A level, best exam I've ever done. C4, I got 80. And then M1, I can't remember what I got, but I got an A. And then S1, I got a B. I got a B in stats. So yeah, but I got like 502 out of 600. And basically to get an A star, yeah, you need you needed to get 180 minimum out of 200 on C3 and C4. Yeah. And I literally got 100 UMS on C3 and I got 80 on C4, guys. So if I had dropped 1 mark on C3, I would have got an A. I don't know what happened that day in C4. My head was just frazzled. Like I just remember it was just I thought I flopped the whole thing. But but yeah, yeah, literally. Um yeah, literally, man, it was crazy. But yeah, my boy Marv, he got 551 out of 600. Like he did a mad thing. Like, do you know what he did? Yeah, he's so good at he doesn't like stats either. He's good at stats, but he doesn't like it, right? So he's so cold at mechanics. Yeah, he taught himself mechanics 2, which is like it's like what it's like further mechanics kind of, and he got a B in that. And he just got an A star as well. But yeah, he's the coldest. He's the coldest. I always tell him. He always tells me that I'm cold. Nah, he knows he's the coldest. We need to big up Marv. Put Marv as a goat in the chat. So when I link him next, I'm gonna show him. Put Marv as a goat in the chat, so he knows that people know what he's on. Okay, put Marv as a goat in the chat. Okay, all right. Yeah, the live will be uploaded right after. Yeah. Okay. So Marv is a maths teacher. He's actually a maths teacher as well. Yeah. Okay. Marv is a goat. Yeah, 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 yeah. Come on. Yeah, 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 yeah. Now he knows. Now he knows. He knows that I've been bigging him up. I appreciate that, guys. I appreciate that, guys. Okay. Yeah, yeah, yeah. How long are we in? So I know where to go to when I watch this back. Okay, yeah, I'll get there. It's after, it's after the binomial. Cool. All right, so we've done that, yeah. Now part B, it says find a range of values of x for which this expansion is valid. Literally, I'm gonna FaceTime him right after this chat. I'm gonna FaceTime him right after this chat. Okay. After this stream. Okay, so when you're doing these ones, guys, yeah, for this one marker to get it, um, I need to stream more. These are fun, I can't lie. Um, if you've got 1 plus ax to the power of n, right, then it's going to be valid. The values of x are going to be valid for just this here, like that, less than 1. And all you've got to remember essentially, right, is that just algebraically, this is just the same as the modulus of x being less than 1 over the modulus of a, right? So wherever your a is, you literally just put it in. It's really, really that simple. So in our case, what was it again? It was 1 minus 5 over 2x, right? So essentially, it's 1 plus minus 5 over 2x to the power of minus 2. Yeah. So our a in this case, this one here is going to go there. So essentially, it's going to be minus 5 over 2x is less than 1. So therefore, the modulus of x is going to be less than 1 over the modulus of that there. And then that number there, like that is just 5 over 2. And then obviously dividing by a fraction, that's just 2 over 5. So the modulus of x is less than 2 over 5, and that's just the same as saying that x is between minus 2 over 5 and 2 over 5. And that is literally it. That will give you the 1 mark. These are the values of x for which your um expansion is valid for. Yeah? So did you play academy football back in the day? I didn't, you know. I didn't, you know. I actually didn't. I just used to play football for fun, but I should have taken it seriously. I can't lie. Nah, do you know what? Yeah, guys, I'm not even joking, yeah. You wouldn't even believe it. Like I don't play football as much anymore, but in my prime, like when I was like 17, 18, 16, I had the quickest feet in my area. Like I'm very, very skillful. I can't lie. Like I'm very, very skillful. Very, very, you can ask anyone. You can ask anyone. But but yeah. Okay. Do parametrics or muscle up. Okay, so let me what about estimations for binomial expansions? That's when I'll see if I can get one after, but for estimations, I think I did one actually earlier today. I'm gonna get one up after, but let me just see. So guys, what have I got left? So I've got an implicit question. I've got a parametric integration question here. I've got a function question here, which I think is just differentiation. What question am I doing next, guys? Let me know. Is it implicit? Is it parametric integration, or is it this one next? Let me know what I'm gonna do. Bro, ignored the muscle up. So what did someone say about a muscle up? Yeah, I've been trying to do a muscle up, Uncle Washballer. It's facts though. It's facts. If I'm not playing pro, then I'm washed. It's as simple as that. Literally. All right, okay. Everyone's spamming parametric. Okay, cool, cool. We're doing parametric. We're doing parametric. Hey, hey. You guys are too funny, man, honestly. All right, so looking at this one, guys. Oh no, no, no. I know what I'm doing. I'm gonna make a new page. This is why I'm organized. Parametrics. So that way if anybody comes on this, um that is a big pause. But anyways, yeah. Uh yeah. What do we think of this question, guys? Put a 0 if you don't know what to do here. You're cooked if this comes up tomorrow, or put a 10 if this is light work. Okay, good stuff. Good stuff. Okay, okay, cool. Okay, cool. Good stuff. Because light work, no reaction. All right. Good stuff. Good stuff. And me, to be honest, guys, you know, is I'm just a fan of football. You know, I just watch football for fun. I'm just a fan. Anyways, let's have a look at this and see. We got. All right. Give me a second. Let me just think. Okay. So, figure three shows a sketch of the curve C with parametric equations: x equals 2 cos t and y equals 4 sin t, where t is between 0 and pi over 2. The region R shown shaded in figure 3 is bounded by the curve, the x-axis and the y-axis, right? Part AI says show, making your working clear, that the area of R is equal to the integral between 0 and pi over 4 of 32 sine squared t cos t dt, right? So, doing this here, let me put this here. So this is our graph, right? And we've got our equations here, like that. And we know that t is defined between 0 and pi over 2. So remember, we're trying to show that. Let's get these show that as well. Actually, there's a lot to get, to be fair. I'm just gonna grab that part. Okay. So we want to define out what this area is, right? Now, if I look at this here, right? Remember, parametric integration, there's a formula, there's a set formula. As long as you remember that, you're good. So it's going to be the integral of y dx dt, right? That is the formula for parametric equation. Yeah. So now what we're going to do is essentially, remember, we're integrating between this part and this value. These are two x values, right? Now, how do we get them? Let's get our limits first. So firstly, that's x is equal to 0, right? What is the corresponding value for t, right? Because that's going to, because remember, this integral, this formula is in terms of t. So I need the limits in terms of t. So what is the value of t when x equals 0? So doing that, x is defined as 2 cos 2t, right? So that's going to be 2 cos 2t is equal to 0, right? And then solving that, that's going to be cos 2t is equal to 0. And then when is cos, do the cos inverse of that, it's in radians, cos inverse of 0 is equal to pi over 2, yeah? So 2t is going to equal pi over 2. And obviously t is going to equal pi over 4, which is fine because it's within range. Yeah. So therefore, that's going to be t equals pi over 4. And by the way, remember, this is the lower limit, by the way. This is when x equals 0. So I'm going to put this there. I'm going to say x equals 0, t equals pi over 4. And then to get this part here, this limit, well, this is when y is equal to 0, isn't it? Right? So what's the value of t when y equals 0? Well, 4 sine t has to equal 0 there, right? So I'm going to do that there. I'm going to say 4 sine t is going to equal 0. Well, sine of 0 is 0. This is just going to equal 0. Like that. Divide by 4. Let me just do it so it's super clear, right? So sine t, divide by 4, you get 0. Sine inverse of 0 is 0. Yeah? So t is equal to 0. And again, that's within the range. Yeah? So what do we have here? We've got x is equal to 0. And we've got t equals pi over 4. And then we've got t is equal to, what was t was equal to 0, isn't it? When y was 0. Yeah. So this is going to be our upper lower limit. So this is actually going to be our lower limit, right? That, and that's going to be our upper limit. So in our integral, it's going to be like this. It's going to be um pi over 4 like that, and it's going to be 0 like that. Yeah. And then we still have to differentiate and stuff. So I'm going to do that now. But I just wanted to get this out of the way first. Yeah. So remember, this is the formula here. What is y? What is the x dt? Yeah. So let me grab these two. See what we get. So it's gonna be doing that. It's gonna be y. So I'm gonna write this is gonna be 0 and pi over 4. Y is equal to 4 sine t. Now dx t, if x is equal to 2 cos 2t, how do we differentiate that? Well, that 2 is a constant. We can times by it. Differentiating cos goes to minus sine. It's going to be minus sine 2t. We times by the inside derivative, so it's going to be times by 2. So overall, it's going to be minus 4 sine 2t. Like that. Yeah? Let me just double check. That's minus sine. That's fine. 2t times by 2. That's perfect. Yeah, that's all good. So it's going to be like that there. And then now, that means it's going to be times by minus 4 sine 2t. Like that. So therefore, so far we're here. We've got minus 16 sine t, sine 2t, like that, dt, and that's going to be pi over 4 and then 0. Now, remember, what we're trying to do is we're trying to show, let's get the show that here, yeah? We're trying to show that we have this here, like that. So, what is the difference between that and that? Well, firstly, what we can do, let's get the angles to be the same argument. So we've got t and we've got a 2t there. Immediately, guys, right? Immediately, double angle formula. What formula comes to mind when you see these? Yeah? Sine 2t, remember, is equal to 2 sine t cos t. Like that, yeah? So we can replace that so it becomes 0 pi over 4, like that, minus 16 sine t, and then it's going to be 2 sine t cos t, like that, dt, like that. And then now we can tidy this up a bit more. I've got a 16, I've got a 2, that's 32. And then I've got sine squared t, and then I've got cos t dt. And this is between 0 and pi over 4. Now that minus can go on the outside, right? Now, whenever you see this here, when you have the limits the wrong way around and you've got a minus, you can literally just reverse it. So there's a rule here. So if I've got the integral of minus, and then b would go here, and then a of f of x, right, dx, this is just equal to the integral of b to a of f of x. Yeah, you don't even need to prove it or anything like that for your exam. You can just quote it. So that's just something to memorize, just in case you see that come up tomorrow. Yeah, so with that being said, bring this down. We're gonna have the integral between pi over 4 and 0, switch the limits, and then 32 sine squared t cos t dt, right? And that is the show that done. Does that make sense, guys? Happy with that? Let me just check the chat because I don't think I've seen it in a while. Yeah. Any tips to do what to do to revise for tomorrow morning before the exam? In the morning of the exam, I remember what I did. I just took it really, really easy. I didn't really do much. Yeah, I think what I do is I look through the spec just to make sure I know everything that can come up. Maybe just look at some light questions and stuff. I don't do too much. Yeah, but yeah, why was the 0 the upper limit at the start? Because remember, if we look at the diagram, right? X equals 0, you agree, is the lower limit when we're integrating in the Cartesian form, right? X equals 0 is that lower limit of f of x, right? What is the corresponding value for t, right? X equals 0. When we solve x equals 0, remember, x is defined parametrically. It's defined as 2 cos 2t, right? So we make that equal to 0 to figure out the corresponding value of t for when x is 0, and we've got t equals pi over 4. So remember, x equals 0 is the lower limit. But because it corresponds to t equals pi over 4, that is why it's the lower limit there. If that's what you're asking. Does that make sense? Yeah. So so you asked about the upper limit, right? So yeah, again, the upper limit was y equals 0, right? At that point, that's the upper limit. The x value is y equals to 0. What is the corresponding value for t? You set y equal to 0. 4 sine t is equal to 0, gives you t equals 0. That's why it's the upper. Because if you look at the diagram, the upper is that one, the lower is that one. So I hope that makes sense. Yeah? Okay. So cool, we've done that one. Let's look at the next question. Double I. It says, hence find by algebraic integration the exact value of r. Right? Okay. So, we just need to integrate this, right? Now, how do we integrate that? Let me just get this here. So, what type of integration are we doing with this one, guys? Yeah, Layla, I'm gonna shy it off at like around 9:30, just before then. Yeah? Exactly. Well done, Matteo. Well done, Rayan. It's the reverse chain rule. Yeah? Jack, you're there now. You've joined us. You're not on the U sub no more, Jack. You sub if you want. Bruh, Jack. Is that how you're feeling? Guys, Jack, yeah, he was not a fan of reverse chain. I told him, listen, trust me, just do it a couple times. It will save you time. Yeah? Okay. So, yeah, let's have a go then. So remember, how could we spot it's a reverse chain rule problem? Well, if you look at this here and you look at this here, forget about the power for now, right? These are derivatives of one another, right? Just irrespective of constants, right? Sine differentiates to cosine and so on and so forth. So what you want to do with this type of question is ask yourself, what would you need to differentiate to get something of this form, right? And look at the power. This is a 2 here. Increase it by 1. Let's try y equals sine t cubed. And I'm going to write like this. If I differentiate that, dy dt, then we know the 3 will drop to the front. It's going to be sine squared t. The 3 will reduce by 1, so it becomes sine squared t. And then I'm going to times by the derivative of what's inside here, which is a cosine, like that. Yeah? So we get that there. And then now, right? What you want to do is say, okay, well, fine. What would I integrate, right? If I was to integrate this here, then we know that we would get back to the start because integration and differentiation are reverse processes. So I would get sine. I'll write it like this now: sine cube t, and I know it's plus t, but I'll leave it off for now, right? So what we need to integrate is something with a 32. So you want to ask yourself, what is the difference between this and that one? The only difference is that constant. 3 to 32. What do we times 3 by to take me to 32? It's just going to be 32 over 3. So therefore, we're timesing by 32 over 3 to get the integral at the bottom, which is what we want. And because this is an equation, we have to do it on here as well. Yeah? So it's going to be 32 over 3 sine cubed t, like that. And that is going to be the integral. Does that make sense? Yeah? Good stuff, guys. Brilliant. Brilliant. Yeah? Good stuff. Yeah, if I've got time, I'll try to do a by parts question. Yeah? Okay, so yeah, this one. So now we know that it's gonna be the integral of 32 over 3 sine cubed t. And then it was between 0 and pi over 4, isn't it? Yeah, like that. So now you just plug in your limits. So it's gonna be equal to 32 over 3 sine of pi over 4. And then because it's gonna be like that, I'm gonna put the cube like that. Take away 32 over 3 sine of 0, like that. And sorry, I forgot the cube, didn't I? So it'll be a cube like that, and then it'll be another bracket like that. Okay, perfect. So sine of 0 is 0, that's just all going to be 0. So it's going to literally be what this is equal to. So I'll put this in the calculator to see what we get. And my calculator is in radians. So 32 over 3 sine of pi over 4, like that. And then that's going to be cubed like that. And that's going to be equal to 8 root 2 over 3. And that is going to be the answer. Does that make sense, guys? We happy with that? Do you always just increase the power and differ on the function with the higher power? Yeah, yeah. There's actually a rule. Give me a second because I remember I did this with my students. Where is the reverse chain rule? Notes. When did I do it? I think I did it in November. November. Reverse chain rule. I can't see it. There it is. There's a rule here. Yeah, this one. I've even clicked it recently. This is the trick here. Yeah. So you say to integrate an expression of the form k f dash of x f to the xn, try f of x plus 1, differentiate and check to then adjust to any constant. That's literally what we did. Yeah. So where's the thing back here? So yeah, literally, that's what we did here, isn't it? Right? We inspected it, right? In our case, the f of x was the sine, the f dash was the cosine, and we said because it was a power of 2 right there, what we did is we increased it by 1. We tried sine t cubed and then differentiated it. Does that make sense, guys? Yeah. Okay. Good stuff. Brilliant. 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 All right. Fantastic. So, yeah, that's done. What was the next question? So you got that there. It says show that all points in C satisfy the square root of ax plus b, where a and b are constants to be found. So this is the next part. Now this is Cartesian stuff, isn't it? Which again is very likely to come up, right? So where was the parametric stuff? It's right here. Yeah. Now, whenever you get these types of question, guys, right, whereby you have a where you have parametrics and they are trigonometric expressions, right? You have to use your trigonometric identities, right? Now, what you want to do is ask yourself, okay, is fine. In terms of these identities, or in terms of the expressions I have, I've got a cosine 2t and I've got a sine t. Are there any expressions that I know that will combine them? And what I mean by that is cos 2t, right? Double angle formula, right? I've got cos 2t. There's three of them. There's cos squared minus sine squared. There is 2 cos squared t minus 1. And there is 1 minus 2 sine squared t. Now, based on the expressions given to you in your question, you want to ask yourself, which is the most reasonable option to pick? The fact that I've got a sine t there, that tells me that I'm going to pick this one. Yeah. So what I'm going to do is I'm going to write x in terms of that one. So it's going to be 2. And then instead of writing cos 2t, I'm going to write what it's equal to, which is this thing here. 1 minus 2 sine squared t. Like that, right? And remember, we know that y is equal to 4 sine t. Yeah. So what we're going to do then is we're going to expand the bracket. So it's going to be x is equal to 2 minus 4 sine squared t. Like that. And then what I can do is say, well, I have an expression for sine t, right? If I just divide by 4, then I know that sine t is y divided by 4. And that's great because I've got sine squared t. That means that y squared over 16 is just sine squared t, isn't it? Right? And then I can plug that there. So therefore it becomes x is equal to 2 minus 4, and then it's going to be y squared over 16. Like that. Sorry, I put a 4 there. Y squared over 16, like that, right? And so now that's going to be x is equal to 2 minus 4 over 16 is just going to be y squared over 4, isn't it? Like that. And then now, remember, what do they want it as? They want it to be, they want y as a subject, yeah? So let's times up by 4. So we're going to have 4x is going to equal 8 minus y squared. Move that there, move that there. We're going to have y squared is going to equal 8 minus 4x, isn't it? Or the way they want it, y squared is going to equal minus 4x plus 8, even though it doesn't actually matter. And then now we need to get y, we just square root. So it's going to be the square root of minus 4x plus 8. Now, remember, when you square root plus or minus, isn't it? Right? Now, how do we know that we can just choose the positive one? Obviously, the show that is, let me write this a bit neater, actually, sorry. Minus 4x plus 8, like that, right? Now, how do we know we can just choose the positive one? Remember your parametric equation, right? Your values were defined between 0 and pi over 2. We're dealing with y, right? Y is either plus or minus. If I was to draw that graph between 0 and pi over 2, well, remember that 4 means it's going to stretch up by 4. So the highest point is going to be a 4, like that. But this is in the first quadrant. First quadrant, everything is positive, sorry. Sine is positive there, cosine is positive, tan is positive, yeah? So therefore, we can just say for sure then that it's going to be y equals the positive root, yeah? Like that. Since t is defined between pi over 2 and 0, right? First quadrant. So y is positive there. And to be fair, in the mark scheme, they've actually got it this way around, like that. Although the question just say, give it like that. So I don't know why, but anyways. Everybody happy with this, guys? Does that make sense? Let's check the chat to see what's going on. Yeah? Okay. Now, honestly, yeah, I'm gonna look at these ads next time when I do a stream. Yeah, so apologies, guys, if they're quite aggressive. I actually have no clue about them. Obviously, I got monetized not too long ago. Obviously, I'm excited and stuff. So when I do these streams, it just says, "Do the ads. Do you want YouTube to do it for you?" I just say yes. I don't have any idea of what's going on, so I'm gonna look into that. So apologies, guys. Yeah, and you should get a full 8 hours sleep. And no, I would not go on Love Island. Absolutely not. Um, cool. So yeah. All right. So we've done that. Let's go to the next one. What was it? Okay. So what do we have? The next part here, it says the curve C has equation y equals f of x, where f is the function. F of x is equal to root ax plus b, where x is between minus 2 and 2, and a and b are constantly found in part B. State the range of f. Okay, so all you've got to do here, right, is essentially just plug in your values, right? Because it's a root function, right? It's gonna be as x gets really, it's gonna be decreasing, isn't it? Right? But it's gonna remember root x is like this, isn't it? Root x is like that, right? So it's monotone. So it doesn't it's not curvy, right? So essentially what I'm saying is that the range, right, is going to be the values of the endpoint. So x equals minus 2 and x equals 2. So you're going to plug those in and see what you get. So plugging those in there. If I plug in x equals minus 2 into there, then what am I going to get? I'm going to get y is equal to the square root of 8 minus 4 minus 2, which is 8 plus 8, isn't it? Which is 16. So it's going to equal 4. And then x equals 2 is going to be y equals 8 minus 4 lots of 2, which is going to be 8 minus 8, which is 0, like that. So the range of this function is between 0 and 4. And also as well, even parametrically, y was equal to 4 sine t, wasn't it, right? What is the range of that function? We did it here. You can even see it here as well. It ranges between 0 and 4. So you can even have looked at the parametric part as well. Yeah? And yeah, that's it. That's it. Does that make sense, guys? Everybody happy with that? Yeah? Okay. Do you know what's so funny? I used to use class diagrams a lot as well. I just memorize it now. Yeah? Okay. Cool. 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 Good stuff. Good stuff. So, because when you look at it here, right? Why couldn't it be minus 4? Because the graph, remember, parametrically it's y equals 4 sine t. This is above the x-axis, right? It has to have positive values. Yeah? Yeah? Good stuff. Cool. Put that there. Let me just check the chat. Okay, let's just see. Just gonna check. Okay, I think that's all good. Okay, right. So, how many questions am I doing left? Um, so what's the time? It's like 9 o'clock. I think I've got one more in me, you know? Did I spell parametrics correct wrong? Why is it telling me? Hold on, what if I do that? Parametric. That's not a word. Ignore. Add to dictionary. Add to my dictionary. Anyways, um, okay. What are we doing next? So I've got two more. How many people are that? 300. Okay. Um, big man, you've been trolling me all live, all stream, you know. You've actually been trolling me. You've actually been trolling me. Don't let me remove you. Don't let me remove you, bro. No, I'm joking. But yeah, which one are we doing, guys? Implicit on the right. Actually, can you see that? Yeah. Implicit on the right or uh functions on the left. Like this is like differentiation. Yeah. Appreciate you, daily politics. I appreciate you. All right, cool. Cool. All right. All right. Okay. Implicit, implicit. Okay. 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 All right. What I'm gonna do, I might just do both, you know. I can't lie, because you guys is just. How do I do a poll? Yeah. I need to do that. I need to be interactive. Poll. How do I do a poll? I don't. Ah, I just realized I'm not on my. I'm not on. You know what I'm gonna do? Yeah. I'm not logged in on this account. It's my brother's account. All right. I'm gonna do both. I'll just do both. I'll just do both. I'll do this one next. So, I'll do this one. Okay. So implicit. Okay. So it says a curve has equation y 4y squared plus 3x um is equal to 6y e to the minus 2x, right? Find the y dx in terms of x and y. Yeah? All right. So we've got a function that's neither explicitly in terms of x or y. They're all mumble jumbled up. So this is quite clearly implicit differentiation, right? So what I'm going to do, let me write out the formula again. So 4y squared plus 3x is equal to 6y e to the minus 2x, like that. We need to go through term by term and differentiate these. Okay. So differentiating this one, we're differentiating this with respect to y. What do? We differentiate 4y squared, normally 8y, and then we times by the dy dx. Remember, we're differentiating with respect to x. 3x will go to 3. And then how do I differentiate this, guys? Mhm. You're going to do the product rule, aren't you? Yeah? So you're going to do the product rule. So you've got 6y, let me write this as 6y e to the minus 2x, like that. And then I'm going to say that u is going to equal 6y. V is going to equal e to the minus 2x. And then, yeah, well done, guys. U dash is going to equal 6. V dash, no, it's not. It's going to be 60y dx. Whoosh, you got to be careful. 60y dx. And then V dash is going to equal, what's it going to equal? It's going to equal minus 2 e to the minus 2x, isn't it? So we get that there. And now, product rule, uv dash plus vu dash. Done. Yeah. So it's going to be 6y times minus 2 e to the minus 2x plus 6 dy dx times by e to the minus 2x. And then let me just tidy that up a bit. So it's going to be, that's going to be a minus 12y um e to the minus 2x, like that. Let me just double check that's all good. And then that's going to be plus 6e to the minus 2x dy dx. Yeah. So that means overall then, the derivative, let me grab this here, copy, like that there, is going to be equal to that. And then this is going to be on the right hand side, like that. Cool. So now remember, we're trying to find out what dy dx is, right? So, let me just see. Okay. Okay. Let me just check. You forgot to do IBX. Okay. Did I forget the IDX? I think I did. I think I. It's all good, no? Just check. Guys, are we happy with that? Yeah, I think that's all good, to be fair. Let me just check my solutions as well. Where is that? I think this is all good. Yeah, all good. Let me just check the chat as well. Haven't missed anything. Okay, I think we're all good here. So yeah, let us continue. Let me just check. Yeah, got that. Perfect. All right, yeah, brilliant. So we're here now. Yeah, that looks good to me. What have I got? So yeah, that looks good. Perfect. All right. So now what we can do is, remember, we're trying to find out what dy dx is. So we're going to make dy dx the subject. So what I'm gonna do is I'm going to just because I don't like dealing with negatives, right? I'm gonna move this one there, right? And I'm gonna move this one over there, right? Just so it looks a bit neater. So that way it's gonna be 3 plus 12y e to the minus 2x. And to be fair, the x and y should swap, shouldn't it? And then that will equal 6e to the minus 2x dy dx minus 8y dy dx, like that. And then now, you know what? I'm gonna just put this the other way. I'm just gonna put this there. I'm gonna put that there. I think it's neater like that. Like that. Okay. And then now take out the dy dx. Do that. And it's gonna be 6e to the minus 2x minus 8y. And then this is equal 3 plus 12y e to the minus 2x. Like that. And then that means that dy dx is equal to 3. Sorry. 3 plus 12y e to the minus 2x over 6e to the minus 2x minus 8y, like that. This is going to be dy dx. Yeah? Okay. So now we've got dy dx. That was part A, wasn't it? Yeah? Brilliant. Now part B says the curve crosses the y-axis at the origin and at the point P. Find an equation of the normal to the curve at P, given your answer in the form y equals mx plus c, where m and c are constants to be found. So the curve crosses the y-axis. Immediately, that's when x is 0. Yeah? So you're going to make x 0 to figure out what values of y that would correspond to. Now, obviously, because it crosses at the origin, you know that one of the y values is going to be 0. So that's something to look out for. So I'm going to get the curve again, right? So that's the curve. And then it crosses the y-axis at the origin at the point P. So it crosses twice. So there's going to be 2 solutions. Yeah. So from there, crosses the y-axis. That tells me that x is 0. So I'm going to plug in x equals 0 into there. It's going to be 4y squared. Nothing's going to be there. It's going to be 6y e to the minus 0, isn't it? Like that. If I plug in 0 into there, that's just going to be 4y squared is going to equal 6y, because e to the 0, e to the negative 0, 0, that's e to the 0, that's 1. So I get that there. Solving that is going to be 4y squared minus 6y is equal to 0. Take out a 2y. I'm going to have 2y there. Is that correct? That's fine. Minus 3 is equal to 0. So 2y is equal to 0. That means y equals 0, which is what we expect because they did tell us that it crosses at the origin. So the other value of y must be at the point P. Yeah? So let's see. 2y minus 3 is equal to 0. 2y is equal to 3. That means that y is equal to 3 over 2. Like that. Yeah? So y is equal to 3 over 2. What are we doing again? Forgot the question. I can't lie. What was the question? Find the equation of the normal. Okay, at the point P. All right, so what is the point P? Let me grab that actually. Okay. So the point P, right? The point P is 0, 3 over 2, isn't it? That's the point P. We want the normal. So we need the gradient. We need the dy dx, don't we? Because we can get the tangent and normal from that. So I need to plug in the values of x and y into there. Once I plug in, that will give me the tangent gradient. And then once I get that, I can get the normal. Yeah? Okay. Okay. So let me plug that in. So it's gonna be dy dx is equal to 3 plus 12. X is 0. I need to be careful because I've got y and x the other way around, isn't it? So what's that? That's gonna be y is 3 over 2, like that. And then e to the minus 2 lots of 0, like that, over 6e to the minus 2 lots of x is 0, and then minus 8y, which is 3 over 2. And I think that's all good. Is that all good, guys? I think that's all good. And then how did I get point P? I got point P, remember, because let's read the question said. It said the curve crosses the y-axis at the origin and at the point P. So I know that we're looking for the y-axis intersection, which is where x is 0. So I subbed x equals 0 into my original curve, right? And that eliminated x, and that gave me an equation in terms of y. We had two solutions, right? Y is equal to 0 was one of them. That is at the origin. And y equals 3/2. That has to have been the point P. Yeah? That's how I got it. Okay. So, uh, let's have a look. All right. So let's continue now. So doing this, to be honest, yeah, you should just put this into your calculator. I can't lie. What's that? 3 plus, what's that? 12/2 is what? 6. 6 times 3 is 18. E to the 0 is 1. So that's 3 plus 18 on the top. On the denominator, that's just going to be a 6 there, I believe. Yeah, that's fine. And then what's that? 8 divided by 2 is 4. 4 threes are 12. That's going to be like that. So it's going to be 21 over minus 6, right? Which is divide top and bottom by 3 is going to be 7 over minus 2. And this is going to be the tangent gradient. Minus 7 over 2. Yeah? Yeah? And then now uh n, the normal gradient, right? You're just gonna do the negative reciprocal, 2 over 7. Yeah? Now the question asks us for the normal to the curve at P. Remember, the equation of a normal y minus y1 is going to equal n, the normal gradient x minus x1. You've got everything you need. You've got the coordinate of P, which is 0, 3 over 2, I believe. Yeah. And the normal gradient is 2 over 7. So you literally just got to plug it in there. Yeah. So therefore, it's going to be y minus y1 is 3 over 2. That will equal n, which is 2 over 7. And then x minus x1 is 0, like that. So that is going to be y is equal to 3 over 2. Sorry, y minus 3 over 2 is going to equal 2 over 7x. And then that means that y is going to equal 2 over 7x plus 3 over 2. And that is it. Make sense, guys? Happy with that? I'm so tired of maths, bro. Don't worry, bro. You've got paper 2 tomorrow and then paper 3 next week, and then you're good to go. Yeah? Okay. Thank you very much, Mongolian farmer. I really appreciate it, man. Okay. Okay. You chose maths because maths is a lit subject. You know? That's why you chose it. Okay. So, all right. Sir, are you going to do a stats and mechanics stream next week? Yeah, I think so. I think so. Should I do one? I was going to do one either on the weekend or the day before. Because I'm just trying to think about like my schedule next week. But yeah, cool, cool. All right. So what's the time? It's 9:18. Okay. I'm naked, I can't lie. I'm naked, guys. I've had a long day. All right, cool. So what are we doing next? That other question, and then we're calling it a day. So where are we? Um, you know what? Actually, after this question, if you guys have got any questions, I'll um let you guys ask a couple of questions about any tips or something like that for tomorrow. But yeah, so this is the last one. I mean, what topic is this? This is just functions, differentiation, and so on and so forth, isn't it? So what do we think about this question, guys? Did I spell differentiation right? Correct? Put a zero if you think I have no clue what to do here. I'm lost, or put a 10 if this is very, very easy. Jack, 10 minutes, 10 minutes, 10 minutes. Okay. 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 Cool. So yeah, let's have a go. Let's have a go. Yeah? Unk's gonna escape the matrix with these ads. Honestly, guys, I apologize, man. I genuinely don't know what the ads are doing. Yeah? Tom 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 Kilday, thank you very much for that, bro. I really, really do appreciate it, man. You guys are gonna do very, very well. Much love. Okay. Thank you very much, Mongolian Farmer, man. Appreciate it, man. Appreciate it. Thank you so much. Okay, let's have a go. So it says the function f is defined by f of x is equal to x plus 5, x plus 1 over x plus 4, minus the ln of x plus 4, where x is an element of the reals, and x is greater than k. Part A says state the smallest possible value of k for 1 mark. Again, when you see this here, this is your domain, isn't it? Right? Remember, just look for bogey spots. We know that this can't be 0, right? This can't be 0. The denominator can't be 0. So if I say x plus 4 is equal to 0, that won't work. So x equals minus 4, right? As well as that, we have a log, right? We know that that can't be more. That can't be, sorry, this has to be greater than 0, isn't it? The argument of a log has to be more than 0. So again, x plus 4 is greater than 0. That means that x is greater than 4, right? All roads leads to this number 4. K has to be 4. Yeah? Sorry, what have I done? I've written 4, minus 4. Apologies, guys. That should be a minus 4 there, like that. Yeah? So therefore, k has to equal minus 4. Does that make sense, guys? Happy now? Yeah. What question is this again? This is the that one. Perfect. Cool. Cool. All right. So, brilliant. All right. I'm so lost. Where is K? K is over there. K is right here. Right there. Yeah? Okay. Easy. So, now part B, it says show that f dash of x is equal to ax squared plus bx plus c over x plus 4 all squared. Yeah. Where a, b, and c are integers to be found. Okay. So, okay. Yeah, no one's saying it can't be minus 4, right? Remember, it's saying x is greater than k. So what we're saying there is that x is greater than minus 4. So I think that's what you're getting. I hope that makes sense. Yeah? Okay. Yeah? All right, brilliant. So part B, show that. So how do we show that? We've got the function there. We've got f dash of x. We need to just differentiate it. Yeah? So let's get that function. And then let's see where we're at. Okie dokie. So that one we need to differentiate, right? So we've got two things to differentiate. Now straight away, that one on the right? We know that that's just going to be 1 over x plus 4. Now, how do we differentiate this term? We've got to use the quotient rule, right? So what I'm going to do is I'm going to expand the numerator and then use the quotient rule. So expand the numerator is going to be x squared plus, what's that? X squared plus an x plus another 5x. It's going to be x squared plus 6x plus 5 over x plus 4. Like that. I'm going to use the quotient rule now. So I'm going to say then that u is equal to x squared plus 6x plus 5. V is going to equal the denominator x plus 4. U dash is going to equal 2x plus 6. V dash is going to equal 1. So therefore, it's going to be VU dash for the quotient rule minus UV dash, right? So it's going to be 2x plus 6, x plus 4, minus 1, and then it's going to be x squared plus 6x plus 5, like that. And then over v squared. So that's going to be x plus 4 all squared. And what I've done here is just the quotient rule, which is vu dash minus uv dash over v squared. That's what I've done there. I've just applied the quotient rule. Yeah? Okay. Okay. Good stuff. So, let's have a go. Let me just see. You guys are funny. So now what I'm gonna do, remember by the way, there's two terms to this function. I've already differentiated this part, so I'm gonna have to bring this back after. I'm just gonna tidy this up before I do that. So I'm gonna expand this. It's gonna be 2x squared plus 2x squared plus a 4x plus an 8x, 2x squared plus an 8x plus a 6x plus 24 minus x squared minus 6x plus 5. I'm just gonna tidy up the numerator. Let me just write I'll write NUM for numerator. and then that will equal, what would that be? 2x squared minus x will be an x squared. I've got ax, these cancel actually, like that. Ax, like that. And then 24, oh, sorry. That should be a minus 5, isn't it? That should be a minus 5. I'm sure you guys have told me. Yeah? Yeah, thank you very much, Matteo. I just clocked it. Appreciate it. Appreciate it. Appreciate you guys. Thank you. So yeah. That is gonna be 24 minus 5, which is gonna be plus 19. Like that. Yeah? So how delayed is this? Because I've done it. Hold on. Okay. Okay. When's the next retwist? My hair's a mess in it. My hair's a mess in it. That's shaded it. That you're shading me, but I know my hair's a mess. I know. I think I'm gonna get one maybe in a couple days. Yeah. All right. Okay. So we've got x squared plus ax plus 19. That's for the numerator. So that way, the actual f dash of x now is gonna become x squared plus ax plus 19 over what was it? X plus 4 all squared. And then remember that term at the end, minus 1 over x plus 4. Yeah. Minus 1 over x plus 4, like that. Are we happy with that? Now let's get what we're trying to show, by the way. It's a show that question. Yeah? We're trying to show that f dash of x is that. Like that. Yeah? So, let's see. Okay. Okay. So we can show it all good. Okay. All right. Brilliant. So we're here now. What are we doing now? So yeah, we just need to combine these, don't we? Yeah? So if I do that, then we need a common denominator. Let me zoom out a bit, and then let me put this here. Yeah. So common denominator. That means that this one is going to be x plus 4 all squared, isn't it? So that means that I'm going to times that by x plus 4. So times top and bottom by x plus 4 to get the same denominator. Now I'm in a position to combine them, right? So therefore, we're gonna have x squared plus ax plus 19. And then remember, when I'm taking away something with more than one term, we need to protect it. So it's like that, yeah? So don't forget that. All squared. And then that's gonna equal x squared plus ax plus 19 minus x minus 4 over x plus 4 all squared. So therefore, we're gonna have x squared plus 7x. What's that? 15 over x plus 4 all squared. And that is going to be f dash of x, right? So your a, b, and c, a is going to equal 1, b is going to equal 7, and c is going to equal 15. And that is part A or part B. Does that make sense, guys? We happy with that? Yeah? Cool. Good stuff. Good stuff. Good stuff. Brilliant. All right, so you've done that now. Thank you very much, Chris, man. Thank you very much, Chris. I really appreciate it, man. You're saving your own A levels, bro, by coming to these streams, watching any videos, revising. You're doing the work, bro, not me. But thank you very much, man. I really appreciate it. So, now part C for 2 marks. Part C for 2 marks, right? It says, hence show that f is an increasing function. So I'm interested, guys. What are your thoughts on this? It's 2 marks, right? We figured out what f dash of x is. How do we show f is an increasing function, guys? What are your thoughts? Yeah. So what you want to do, right, is you actually just want to inspect this, right? If f is an increasing function, right, that means that your gradient function is greater than 0, isn't it? So if your gradient function is greater than 0, right, then that will prove that it's increasing. Now, this is our gradient function. So we choose to show that this here is always positive. Now, we're dealing with a fraction here. So let me just rewrite this. I don't like the way I've written this. It looks quite nasty. Hold on. So it's x squared plus 7x plus 15 over x plus 4 all squared, isn't it? And that's better. So we have a fraction. How can a fraction be positive, guys? There's two options. Option one is if the numerator is positive and the denominator is positive, or both the numerator and denominator are negative, right? So we need to show that we have one of these. So let's look at the numerator, x squared plus 7x plus 15. Well, this is a quadratic. How can we show this is always positive? Well, we know it's a U shape, right? Now, does it intersect the x-axis? Well, we can figure that out by applying the discriminant, right? Discriminant b squared minus 4ac is going to be 7 squared minus 4 lots of 1 and 15, like that. That's 49 take away 60, which is equal to minus an 11, which is less than 0. Yeah. So therefore there are no roots. Yeah, or no real roots, I should say. Right. I'm sure the further maths will tell me that. Anyways, yeah, there are no real roots, so it doesn't intersect. So therefore, x squared plus 7x plus 15 is entirely above the x-axis. Yeah. So therefore, it's positive for all values of x. So that is done. Yeah. Now, the denominator, x plus 4 all squared. Now, remember, we're squaring something. No matter what goes in there, it's either going to be 0 at the minimum, right? But remember, the domain of this function, right? Remember, they told us at the very beginning, they said state the value of k. I need to go all the way up. K was minus 4. X was greater than minus 4. So we know it can't be 0 anyway. So therefore, this is always greater than 0, right? X plus 4 all squared is greater than 0. Yeah, it's not even greater than or equal to because x is never equal to minus 4 from the domain, right? That's not part of the domain. So therefore, what we've said then is that we have f dash of x, right, is actually equal to the numerator, which is positive, over the denominator, which is positive, which is overall positive, right? So what we could say is f dash of x is always positive, for all x. And so that would mean that f is increasing. And that's it. That makes sense, guys? Happy with that? Yeah. Okay. Okay. Can you name 10 books? I don't think I can, I can't lie. But yeah, big man, big man. I'm gonna find you. I'm gonna find you, bro. I'm gonna find you, bro. Big man, I'm gonna find you, bro. Anyways, but yeah, how are you guys feeling, guys? I think I'm gonna wrap it up now. Um, because yeah, it's getting a bit late. But yeah, how are you guys feeling for tomorrow? What I'll do is just in case anybody has any last minute questions, I'll just give the floor just in terms of like any last minute questions that you guys may have. So so yeah, let me just put this up there. Okay, I think that's all good. But yeah, if you guys have any questions, then just let me know. Let me check the chat as well. But yeah. Why did you forget the denominator? Uh I don't think we've read it all. Natasha, you got this, don't worry. Can you show how to integrate cos squared real quick? To integrate cos squared, right? You have to just use the double angle formula. That's it. You just have to use the double angle formula. Literally. Just the double angle formula. So let me just do it. Give me a sec. Um so remember, if I'm integrating cos squared like that, you want to get rid of this power. Yeah. So double angle formula cos 2x is equal to 2 cos squared x minus 1. So what you want to do is you want to rewrite this in terms of that. So that's going to be cos 2x plus 1 is equal to cos squared x, like that. Sorry, 2 cos squared x, sorry. And then divide by 2, you're going to have a half cos 2x plus a half, like that. Is that correct? Yeah, that's cos squared x. So integrating that is going to be the same as integrating that. So that one is now easy. That's going to be a half. That's going to be what? Sine 2x and then times by a half plus a half x plus c. So it's going to be a quarter sine 2x plus a half x plus c. That makes sense? But yeah, yeah, okay. But yeah, cool, guys. Best of luck for tomorrow, guys. It's been a pleasure. Let me know how it goes. I actually need to lock in like you guys tomorrow. While you guys are doing the exam tomorrow, I'm going to um I'm going to finish doing my paper three, predicted paper three. Yeah. Are you using a Unk or mouse? I'm using a graphics tablet. So I'm using this right here. It's like £50 on Amazon. It saved my life, honestly. Yeah. So I'm using that. What was I gonna say? Uh, you're welcome. You're welcome, man. But yeah, guys, best of luck, man. Any tips I would say, get to bed early. Get to bed early, so don't go to bed too late. You guys have done the work, right? You've done lots of. You've even done the first exam, so you know how these exams work, right? So you'll be good. Um, Anything else I would say? Always read over the specification, just in case there's anything that you're not familiar with. Um, but yeah, yeah. Best of luck, man. I haven't revised paper three for like 5 months. Paper three. Okay, when is early? Like 10 o'clock. Yeah? You guys are funny. Um, okay. But yeah, guys, I'm gonna end it here. It's predicted paper update for the topics which came already. No, no. So literally, paper two was like from 2, 3 weeks ago. So I just made two different papers. Yeah. But guys, we're gonna leave it there. Let's end with W's in the chat because that's what we're all collecting tomorrow. We're gonna spam W's, guys. Spam W's in the chat. Yeah, spam W's in the chat. This could come up. No worries, man. No worries, man. No worries, man. Guys, good luck. Love that. Love that. Loved it. Take it easy. I'll see you guys soon, man. Take care.